The National Electrical Code, or NEC, does not specifically require spare capacity in panel boards. Whether or not to include spare capacity is considered a good design practice, allowing for future expansion and modifications to the electrical system, but it is not mandated by the NEC. An electrical inspector's claim that spare capacity is a code requirement is incorrect, as the NEC does not contain any such provision. Therefore, it's essential to distinguish between recommended design practices and enforceable code requirements. A panelboard's purpose is to distribute electrical power to various circuits within a building or system. It typically consists of a metal enclosure containing circuit breakers or fuses that protect individual circuits from overcurrents. The NEC provides comprehensive guidelines for the installation, wiring, and protection of panelboards to ensure electrical safety. Some key aspects covered by the NEC include ampacity ratings, overcurrent protection, grounding, and working clearances. While the NEC focuses on these fundamental safety aspects, it doesn't delve into the specifics of spare capacity. The decision to incorporate spare capacity in a panel board is primarily driven by engineering judgment and anticipated future needs. There are several reasons why an electrical designer might choose to include spare capacity in a panel board. Firstly, it allows for future expansion of the electrical system without the need to replace the entire panel board. As a building's usage changes or new equipment is added, spare capacity can accommodate the additional electrical load. Secondly, spare capacity can simplify maintenance and troubleshooting. If a circuit breaker fails or needs to be replaced, having spare capacity allows for a quick and easy replacement without disrupting other circuits. Thirdly, spare capacity can improve the overall reliability of the electrical system. By distributing the load across multiple circuits, spare capacity can reduce the risk of overloading any single circuit. Despite the benefits of spare capacity, there are also some potential drawbacks to consider. Firstly, spare capacity can increase the initial cost of the panel board. A larger panel board with more circuit breakers will typically be more expensive than a smaller panel board with fewer circuit breakers. Secondly, spare capacity can take up valuable space. In buildings with limited space, a larger panel board may not be feasible. Thirdly, spare capacity can lead to unused circuit breakers, which can be a waste of resources. The decision of how much spare capacity to include in a panel board is a balancing act between the benefits and drawbacks. There is no one-size-fits-all answer, as the optimal amount of spare capacity will vary depending on the specific application. As a general guideline, it is often recommended to include at least 20% spare capacity in a panel board. This means that if a panel board has 24 circuit breaker spaces, at least 5 spaces should be left empty for future expansion. However, this is just a guideline, and the actual amount of spare capacity may need to be adjusted based on the specific needs of the project. It's important to note that even if spare capacity is not required by the NEC, other codes or standards may require it in certain situations. For example, some building codes may require spare capacity in panel boards that serve emergency systems or critical equipment. It's always important to check the applicable codes and standards to ensure compliance. The NEC addresses panel boards in Article 408. This article provides requirements for construction, installation, and overcurrent protection of panel boards. While Article 408 does not explicitly mention spare capacity, it does include requirements for calculating the load on a panel board. Section 408.36 requires that the calculated load on a panel board not exceed the rating of the panel board. This means that the panel board must have sufficient capacity to handle the anticipated load. While this requirement does not directly address spare capacity, it does indirectly encourage designers to consider future expansion when sizing a panel board. In addition to Article 408, the NEC also includes requirements for overcurrent protection in Article 240. This article requires that each circuit in a panel board be protected by an overcurrent device such as a circuit breaker or fuse. The overcurrent device must be sized to protect the circuit from overloads and short circuits. The NEC provides tables and guidelines for selecting the appropriate overcurrent device for a given circuit. Another important consideration when installing a panel board is grounding. The NEC requires that all panel boards be properly grounded to protect against electrical shock. Article 250 provides detailed requirements for grounding electrical systems. The grounding system must be designed to provide a low impedance path for fault current to return to the source. This helps to ensure that overcurrent devices will trip quickly in the event of a fault. Working clearances around panel boards are also important for safety. The NEC requires that sufficient working space be provided around panel boards to allow for safe operation and maintenance. Section 110.26 specifies the minimum working clearances for electrical equipment. The working space must be clear of obstructions and must provide adequate headroom and access. In summary, while the NEC does not explicitly require spare capacity in panel boards, it is a good design practice that can provide several benefits. The decision of whether or not to include spare capacity should be based on engineering judgment and anticipated future need. It's important to check the applicable codes and standards to ensure compliance. The NEC provides comprehensive guidelines for the installation, wiring, and protection of panel boards to ensure electrical safety. These guidelines cover aspects such as ampacity ratings, overcurrent protection, grounding, and working clearances. By following these guidelines, electrical designers and installers can ensure that panel boards are installed safely and reliably. When evaluating the need for spare capacity, consider the long-term implications of not including it. Retrofitting a panel board to add capacity later can be significantly more expensive and disruptive than including spare capacity during the initial installation. This is especially true in situations where the existing panel board is difficult to access or located in a confined space. Moreover, consider the type of loads that the panel board will serve. If the panel board will serve critical loads, such as emergency lighting or life safety systems, then spare capacity may be even more important. In these situations, the ability to quickly and easily add new circuits can be crucial. When selecting a panel board, it's important to choose a panel board that is properly rated for the anticipated load. The panel board's ampacity rating should be sufficient to handle the total connected load, including any future expansion. It's also important to consider the panel board's short circuit current rating, which is the maximum amount of fault current that the panel board can safely withstand. The short circuit current rating should be higher than the available fault current at the panel board's location. Another important factor to consider when selecting a panel board is its environment. If the panel board will be installed in a damp or corrosive environment, then it should be protected by an enclosure that is specifically designed for that environment. The enclosure should be made of a corrosion-resistant material and should be properly sealed to prevent moisture from entering. In addition to the NEC, other standards may also provide guidance on panel board design and installation. For example, the National Electrical Manufacturers Association, or NEMA, publishes standards for panel boards and other electrical equipment. These standards provide detailed specifications for the construction, performance, and testing of panel boards. The Institute of Electrical and Electronics Engineers, or IEE, also publishes standards related to electrical power systems. These standards cover topics such as power system protection, grounding, and coordination. Consulting these standards can help to ensure that panel boards are designed and installed in accordance with industry best practices. Finally, it's important to remember that electrical work should only be performed by qualified and licensed electricians. Working with electricity can be dangerous, and it's important to follow all safety precautions. Always to energize the panel board before working on it, and use appropriate personal protective equipment such as gloves and safety glasses. By following these guidelines, you can help to ensure that panel boards are installed safely and reliably. In addition to the design considerations, the NEC also provides specific requirements for the installation of panel boards. Section 408.38 covers the location of panel boards, requiring them to be readily accessible and not located in bathrooms, toilet rooms, or clothes closets. This ensures that the panel board can be easily accessed for maintenance and repairs, and that it is not exposed to moisture or other hazards. Furthermore, Section 408.3060 addresses the support of panelboards, stating that they must be securely fastened to the surface on which they are mounted. This prevents the panelboard from becoming loose or falling, which could create a safety hazard. The NEC also includes requirements for the identification of circuits within a panelboard. Section 408.4 requires that each circuit be clearly labeled with its purpose or function. This helps to prevent confusion and makes it easier to identify the correct circuit for maintenance or troubleshooting. The labeling must be durable and easily readable, and it should accurately reflect the circuit's intended use. When working with panel boards, it's important to be aware of the potential hazards involved. Electrical shock is a serious risk, and it's essential to take precautions to protect yourself. Always to energize the panel board before working on it, and use appropriate personal protective equipment, such as gloves and safety glasses. It's also important to be aware of the potential for arc flash. Arc flash is a dangerous electrical explosion that can occur when a short circuit or other fault occurs in a panel board. Arc flash can cause severe burns, blindness, and even death. To protect yourself from arc flash, it's important to wear appropriate arc-rated clothing and equipment. The level of protection required will depend on the specific hazards involved. The NEC requires that electrical workers be trained in arc flash safety. Section 110.16 requires that electrical equipment be marked with a warning label that indicates the potential for arc flash. This label helps to alert workers to the potential hazards and encourages them to take appropriate precautions. In addition to arc flash, there are other potential hazards associated with panel boards. These include the risk of fire, explosion, and exposure to hazardous materials. It's important to be aware of these hazards and to take precautions to protect yourself. For example, panel boards should be kept clean and free of debris to prevent the risk of fire. They should also be inspected regularly for signs of damage or deterioration. If any problems are found, they should be repaired promptly. In conclusion, while the NEC does not mandate spare capacity in panel boards, it's a prudent design practice that offers several advantages. It facilitates future expansions, streamlines maintenance, and enhances the system's reliability. The decision to incorporate spare capacity hinges on engineering expertise and anticipation of future requirements. Always adhere to relevant codes and standards to guarantee compliance and safety. Electrical design and installation demand precision and knowledge, emphasizing the importance of consulting qualified professionals for any electrical work. By considering these factors, you can ensure that your panel boards are designed and installed safely and reliably, providing a solid foundation for your electrical system. Remember to prioritize safety, follow best practices, and consult with qualified professionals to ensure the integrity and reliability of your electrical installations.